Hi, my name is Jeff Silberman. I'm a Technical Solutions Architect at Cisco Systems. This video is part of the UCS Advantage series designed to highlight that many common data center operational tasks become much simpler to address with Cisco's unified computing system. This segment will highlight how the unified computing system greatly simplifies the management of a server's firmware and BIOS images. Cisco's UCS blades and rack servers both have fairly standard motherboard designs that use industry standard components with respect to CPUs, memory, baseboard management controllers, local disk controllers, and so forth. Most of these elements run particular firmware versions and BIOS versions on the motherboard. As is the case with all servers, firmware and BIOS versions change over time, and one of the more difficult tasks in data center server management is the periodic updating of BIOS and firmware versions across multiple servers. It's typically a manual process that must be done in serial for each server, one at a time. With Cisco's UCS, we have achieved a very deep level of hardware state abstraction for our definitions of logical servers or service profiles. This deep modeling of the logical server has allowed us to define the server's firmware and BIOS versions as an attribute of the logical server, rather than having a logical server simply be subject to whatever version of firmware and BIOS happens to be running on a particular physical blade. Let's take a look at how this works. We'll start by going into the UCS Manager, which is our single point of management for all server resources in this domain. And let's take a look at the SQL Service Profile template, which is a description for a bare metal set of servers that would be running SQL Server as an example. This template description contains the definition for 2 virtual HBAs as part of the storage configuration and 2 virtual NICs as part of the network configuration. The boot policy here defines how the set of servers would boot, from which devices and in which order, including the worldwide port name of the SAN boot target. And here under the Policies tab, we see which version of host firmware and BIOS version that should be deployed for the set of servers that get instantiated from this template definition. Here you can see there might be 3 possible versions to choose from: an older rollback version, a current production version, and maybe a new release version that needs to be qualified in a dev test environment prior to rolling out in production. One important thing to note about this template is that it is an updating template. This highlights a very powerful feature of UCS. It says that once we use this template to instantiate actual individual service profiles, the relationship between those individual service profiles and this template will be preserved. This means that any changes to the template will get reflected immediately to the instantiated service profiles. So now let's use this template definition to go and instantiate 10 actual SQL service profiles or SQL servers. And there they are. Note that each individual service profile will be running the host firmware and BIOS package that corresponds to the current production version 1.2.1b. I didn't have to define it for each individual service profile. The value or version came from the template definition. And here you can see the state of all physical servers. These servers were part of the server pool that was associated with the SQL template. And their config status indicates that right now these physical servers are being effectively programmed with the personality of each individual SQL service profile, each programmed with the worldwide port names and the MACs, the boot order, and the prescribed version of the host firmware and BIOS version, 1.2.1b. Now assume that another group had qualified the latest version of host firmware in BIOS, 1.3.1m, and that we're now ready to roll this version into production. If you had to do this with standard servers, you'd have to schedule hours and hours of downtime, since changing the BIOS typically requires you to be at the server's console. It is a manual process that must be done on each individual server, one at a time. But with UCS and updating templates, this task becomes much simpler and faster to accomplish. Here we change the firmware policy version on the updating template, which will then get pushed to all instantiated service profiles automatically and in parallel. Now, of course, in a production environment, since this is a service impacting operation, I would have, of course, done a clean shutdown before saving the changes here and proceeding. In any event, the UCS manager will notify me that this is a service impacting operation and prompt me whether to continue or not. But once I proceed with the change, then all instantiated service profiles will get updated with the new host firmware and BIOS versions immediately. The subsequent UCS Utility OS Association cycle will program all the blades in parallel with the appropriate BIOS and firmware version, and then restart all the servers in parallel. To recap, updating a server's firmware and BIOS used to be both a manual and a serial process, involving hours and hours of downtime and manual intervention. With Cisco's unified computing system, a server's firmware and BIOS can be updated in an automated fashion and in parallel across any number of servers, making data center operations much simpler.